Hey there, and welcome. Have you ever stopped to think about how your phone connects to Wi-Fi, or how you can send an email to the other side of the world with just a single click? Well, it's all thanks to the magic of computer networking. And if you're totally new to this world, don't worry. Today we're starting right from the beginning, from absolute zero. Our journey today is broken down into 5 parts. First, we're going to unpack what a network actually is. Then we'll look at the key components that make it all work. After that, we'll explore the different types of networks, from the tiny to the truly massive. Then, we'll dive into the huge world of the internet. And finally, we'll learn about a special kind of network called an intranet and wrap everything up. So, let's get started.
All right, let's kick things off with the first and most important question. What exactly is a computer network? Trust me, it's not rocket science. In fact, it's an invisible but absolutely essential part of our daily lives.
Think of it like this. Just like we humans have a social network, friends and family, where we share ideas and photos, computers have their own network too. They connect to each other so they can share information, files, and even things like printers. At the end of the day, it's all about sharing.
So, what do we get out of connecting a bunch of computers? A whole lot. First, file sharing. Think about sending a huge video file to your friend instantly. Second, resource sharing. Imagine 10 people in your office, but only one printer. Without a network, that would be a nightmare. It also saves money, improves security, and lets you keep all your important data in one safe, central place.
Okay, so now that we get the what, let's dive into the how. What are the actual pieces that make up a network? Think of it like building with Legos. We're going to need a few different kinds of blocks. These are the building blocks of a network that bring it to life.
At the heart of the network is the server. It's the boss computer that manages everything and holds all the data. Every other computer connected to it, like your laptop, is called a workstation or a client. Now, to manage the traffic, we've got 2 key devices. A hub is kind of like a loudspeaker. It shouts every message to everyone. But a switch is like a smart mailman. It delivers each message only to the exact address it's meant for. Way more efficient.
Now, let's talk about the devices that tell data where to go. Think of these as the traffic cops of the network. A bridge is like a local road, connecting 2 similar neighborhoods, like 2 office networks. A router is like a major highway interchange. It connects different cities or networks and sends data along the best possible path. And a gateway is like an international airport. It connects 2 completely different countries or networks with different rules where you need a passport to get in.
And here's a fun little twist. Sometimes our highway interchange, the router, can also act like a small airport or a gateway. That's because it can actually translate data between networks that speak 2 different languages or protocols, just like a translator at an airport helps people from different countries communicate.
So how does data actually get from point A to point B? Well, there are 2 main ways. First, you've got guided media, which means physical wires. Think of this as a superhighway for data, like that thick Ethernet cable plugged into your computer. The other way is unguided media, or wireless. This is like magic. Data travels on invisible waves through the air, just like your phone's Bluetooth or your home's Wi-Fi.
Now that we know what networks are and what they're made of, let's look at their different shapes and sizes. Are all networks the same? Not at all. They're usually classified based on how big they are and how they're laid out.
Based on geographic size, there are 3 main types. First up is the LAN, or local area network. Think of this as your home or your office. Then there's the MAN, or metropolitan area network, which can cover an entire city. And then you have the giant WAN, or wide area network, which connects the whole world. The internet is the biggest WAN of them all.
There are also 2 other special networks you're probably already using. A PAN, or personal area network, is your own little personal bubble. When your headphones connect to your phone via Bluetooth, that's a PAN. And a CAN, or controller area network, is basically the nervous system of your car, connecting everything from the engine to the power windows.
Okay, now let's talk about network topology. That's a fancy-sounding term that simply means, how do we connect the dots? It's the blueprint or the map of the network showing how everything is physically or logically connected to everything else.
There are a few popular designs. In a linear or bus topology, everything is connected to a single main line, kind of like clothes on a clothesline. In a star topology, just like the name suggests, everything connects to one central point, like the spokes on a wheel. And in a ring topology, everyone holds hands in a circle.
A tree topology is like a star that grows branches, just like a family tree. And finally, you have the mesh topology,
which is the ultimate connector. Imagine everyone in the room being directly connected to everyone else. If one connection breaks, no problem. There's always another path for the data to take. It's super reliable.
All right, now we're ready for the big one, the king of all networks, the internet. Let's dive into this massive world and learn a few key terms to help us speak its language.
So what is the internet, really? It's the ultimate WAN, a massive global web of millions and millions of smaller networks all connected together. That's why it's often called the network of networks. It's like connecting every city, town, and village in the world with one giant system of roads. To navigate the internet, we need some basic vocabulary. You land on a website, which is just a collection of web pages. Those pages are written in a language called HTML. See that blue clickable text? That's hypertext. And the link itself is a hyperlink. And where does all this stuff live? On a powerful computer called a web server.
Every website has a unique address, called a URL. Think of it just like a mailing address. The protocol, like HTTP, is the type of mail service. The domain name is the city and street name, like google.com. The path is the house number, and the file name is the specific room inside that house you're looking for.
Every single device on the internet has its own unique identifier, called an IP address. It's kind of like its phone number. There are two types. A static IP is like your home address. It's permanent and doesn't change. Websites use these. A dynamic IP is more like a hotel room. You get assigned a temporary address each time you connect to the internet. That's what most of us use at home.
We are nearing the end of our journey. For our final stop, we're going to learn about a special, private network called an intranet, and then we'll tie together everything we've learned today.
So, what's an intranet? Think of it as a company's own private, secret internet. It uses all the same technology as the public internet, but it's walled off for employees only. It's like an invite-only party, whereas the internet is a giant public festival.
So, let's wrap it all up. Today, we learned that networks are all about sharing. We discovered the building blocks that make them work, like servers and routers. We saw that they come in all sizes, from your home LAN to the global WAN, and can be arranged in different shapes or topologies. And we learned the language of the ultimate network, the internet. So next time you're at home, take a look around. Can you spot your PAN, LAN, and WAN connections? Your Bluetooth headphones, your Wi-Fi router, your smart TV, they're all part of this incredible connected world. Give it some thought. Thanks for joining me on this explainer. Until next time, stay connected.